Welcome back. Unit 4, Types of Chemical Reactions. Indicators of chemical reactions. So whenever there is any two substances, when they are mixed, the indication that there is a chemical reaction: number one, a gas can be formed; number two, light can be produced; number three, an explosion can also occur. The number four, there can be a temperature change. It either temperature can be absorbed, which means heat is absorbed, so temperature will reduce, or heat is released, temperature will increase. So these are endothermic and exothermic reactions. And number five, a new odor is produced. So sometimes you can see a gas being formed, and this gas can also have an odor, indicating that a new substance has been formed. But sometimes the formation of a substance can just create an odor. So the next point is precipitation. Precipitation, it means like you mix two substances, and when they react, there are some precipitate. Precipitate, it means there is something that is deposited at the bottom of the container. Then the last one, a color change. So these are the basic indicators that indicators of chemical reactions. 5 types of chemical reactions. So the synthesis. Synthesis, it means is two substances like A plus B, they are forming C. So it's a synthesis, suppose they are combining. Then there's decomposition, like A plus B, they decompose to A and B. Then there's single displacement reaction. So it will be like A plus B, AB plus C is equals to AC plus B. It means C, it displaced B. Then double displacement is AB and BC, and the DC. So it will be AC plus BC. So basically, C. Okay, no, here it's a mistake here. I need to say it's A, C plus BD. So this is a double displacement. Then there's a combustion. Combustion is like the burning. So usually when there's a combustion, there's carbon dioxide and the water produced. So combustion is mainly for hydrocarbons. These are your butanes, your petrol, all those things. Hydrocarbons, that's where they normally ask questions relating to combustion. So we'll go into these types of reactions. So for synthesis occur when two substances combine to form a single compound. So in this case, A and B, they combine to form AB. Then, so it's reactant to form product. So the example is hydrogen. If it combines with water, with oxygen, it forms water. H2O is water. Then carbon and oxygen, when they combine, they form carbon dioxide. So these are synthesis reactions. Decomposition reactions. Decomposition reactions are opposite of synthesis reaction. They occur when compounds break into similar compounds. So AB, it decomposes to form A plus B. So its product is forming reactant and reactant. So example is water can decompose to hydrogen and and oxygen. Then decomposition of mercury oxide to form mercury plus oxygen. So decomposition is a compound breaking down into smaller compounds. So this is basically. Then single displacement reaction. In a single displacement reaction, a neutral element becomes an ion as it replaces another ion. So element plus compound to form compound as element. So the other element is displaced. So A plus BC, it forms AC, which means A displaced B. So A displaces B here, then it becomes AC plus B. So then A plus B forms BA. So these can be different ways of. So it depends with which substances are being reacted to. So for example, if there is iron plus copper sulfate, copper is displaced, so it becomes copper plus iron sulfate. So some of these things, they have to do with the reactivity, because iron is more reactive than copper, so it displaces it. So but this is just an example of a single displacement reaction. So double displacement reaction occurs when a metal displaces a metal in a compound with and a non-metal displaces a non-metal in a compound, forming two new compounds. So A, B plus BC, so it displaces each other to form CB and BD. So which means C, it combines with B to form CB. Then D combines with A to form AD. So this is a double displacement. So it's compound plus compound to form compound and compound. So these are examples. Iron, silver nitrate plus sodium chloride. Silver. So chlorine, it displaces nitrate to form silver nitrate. Then the nitrate combined with the sodium to form sodium nitrate. So the same one below, potassium sulfate and beryllium nitrate, they displace each other. So the sulfate, it displaces the nitrate here. Then the nitrate comes and joins here. So it's a double displacement reactions. So this is the next one is combustion reactions. So combustion requires when a hydrocarbon reacts with oxygen to produce carbon dioxide and water. So when a hydrocarbon it is with carbon and hydrogen. So the XY is just symbols that we put to represent different number of carbons and different number of hydrogen. So the number of carbons and hydrogen, they determine which type of hydrocarbon you have. So in this case, we have C5H12 plus oxygen to form this one, carbon dioxide and water. But remember, this one is not balanced. So if we were to balance it, you see this side, there is 5 carbons. So in this side, there should be also 5 carbons. So if you put 5 here, then hydrogens, there are 12. This side, they've got 2. So if you put 6 here, 6 times 2, it becomes 12. So the oxygens, it's 6 plus 10, 16. So here you put 8. So a balanced one will be C5. Okay, sorry for that. Just want to put to form 5 plus 6H2. So you can see 5 carbon, 5 carbon, 12 hydrogen, 6 times 2, 12 hydrogen, and 16 oxygen, 8 times 2, 16, then here 5 times 2, 10, plus 6, 16. So it's a balanced. So this is a form of combustion. So combustion is hydrocarbon plus oxygen to form carbon dioxide and water. So these are typical combustion reactions. So you just remember this. Then try this. Classify the following types of reactions. So remember we did 5 types of reactions. So you must classify according to say, is it a synthesis, is it a decomposition, is it a displacement, is it a single displacement or a double displacement or a combustion. So in this case, can you try to name this? So you can pause the video so that you can attempt. So I hope you have tried. Let's check the solutions. So for number 1 is double displacement, because it's compound plus compound to form compound plus compound, and you can see there were 2 displacement here. The OH was displaced and it went here, and the nitrate was displaced and it went here. So it becomes a double displacement. So this one, you can see this is a hydrocarbon and oxygen, so to form water, carbon dioxide and water, so you already know it's a combustion. Then the other one is a single displacement, because the ion is coming to displace the sodium, so it's a single displacement. Then the other one is a double displacement, because it's compound plus compound. So you can see the sulfate is going here, this part is going this side, and the OH is going that side. So it's a double displacement. So synthesis is the next one, because 2 substances are combining to form one. So this is a synthesis. Then a decomposition is 1 substance is dissociating into 2 substances. So this is a decomposition. So sometimes you might be asked to classify them in multiple choice, and sometimes in another types of questions. So solubility. Solubility is the ability of a solid, liquid or a gas to dissolve into a solvent and form a solution. So like for example, let's say you have got your water in here. So if you put sodium chloride, which is your salt, into the water, here H2O, the sodium chloride, the salt will dissolve in water. So in other words, we are saying sodium chloride is soluble. It means it can dissolve in water. But you might find out if you take a different substance which is not water, sometimes it won't dissolve, because different chemicals behave differently with other substances. So solubility of a substance is fundamentally depends on the solvent used, as well as the temperature and pressure. So here we are assuming at room temperature, which is room temperature and pressure. So it's normally 25 degrees for room temperature and 1 atmosphere. Or something like that, for you can cross check. So basically the other part, solubility of a substance is measured by the concentration of the saturation solution. So what we mean is like, let's say you have got 1 liter of water. So you'll be gauging like how many grams of sodium chloride can you add before it starts to accumulate at the bottom here. So when it starts to accumulate at the bottom, it means you have passed the point of saturation. So before the liquid is saturated, the water, whenever you add, it will dissolve and nothing will be shown at the bottom. So by the moment you start to see deposit at the bottom, it means the water, like in case of 1 liter, as an example, will no longer be able to accommodate any additional salt. So the solubility of a substance is measured by the concentration of the saturation solution. When additional solid no longer increases the concentration of the solution. So basically that's what I was trying to explain. The degree of solubility ranges widely depending on the substances. Infinitely soluble, which is fully miscible. E.g. ethanol in water is insoluble. Then silver chloride in water. Okay, so basically what we are saying here, we are saying ethanol in water is fully mixable. What it means, it is not limited. You can continuously add water into ethanol and it will continuously dissolve, and there won't be any issues. You continuously add and add and add, and nothing will change. But for silver in water, silver chloride in water, it's insoluble. It means it will not dissolve. It will form deposits. When you add sodium silver chloride, it will just form deposit. It won't dissolve. So here is just a scale, like to say, the solubility of substances, they differ. So here we are saying infinitely soluble, and the other end insoluble. So in this case, we gave an example of silver chloride and water, H2O, the insoluble, but here ethanol. It's ethanol in water, which is H2. It's infinitely soluble. So that's what. So the solubility, it depends with the combination of substance that are being used. So in this case, infinitely one, it was ethanol and water. Then insoluble example, silver chloride and water. There are many substances that do not dissolve in other substances. So these are just the basics we are showing you here. So the fourth point, solubility does not depend on the particle size. So basically what we mean is, like, let's say you've got a grain of salt this size and a smaller one. If you put it in water, it will dissolve. So it does not depend on the size, but the speed of dissolving will be different, because smaller particles, they dissolve fast. So solubility does not depend on particle size. Given enough time, even large particles will eventually dissolve. Okay. Generally, the solubility of most particles increases with temperature, but gases tend to decrease. So basically, if you want to do an experiment at your home, you can have 2 cups or 2 glasses, then another. So here you can just take maybe tap water, then here it's boiled water, like just immediately after being boiled. So if you put the same amount of salt at the same time, you see that it will dissolve faster here. It will dissolve faster. Yeah, I wanted to write here. It will, so here the temperature will be like around 100 degrees, like if you take it after the kettle is boiled, and here the temperature of the water, I'm not quite sure what it will be depending, but we can assume it will be around maybe 40 degrees, for example. So here it will dissolve faster because it has got a higher temperature. So higher temperature, it means the the water is more energetic. The particles inside the water are more energetic than the ones at 40 degrees. So it will assist in the dissolution. Because remember, temperature, it also affects the rate of chemical reaction. So for most substances, generally speaking, temperature increases the rate of dissolution. So solubility of most substances increases with so I just want to check where we are. Okay, yeah. Okay, no, it's fine. Okay, let's move on. So this is an example of the solubility table. So you can see like this is your temperature this side, and here is the solute per 100 grams. So it means let's say this is potassium iodide. So it means the solubility is increasing with temperature. You can see at 0 degrees it's at this level. At around almost 25 degrees, it will be solubility will be like around 150. You can take another substance, for example, sulfur dioxide is a gas. You can see that solubility is decreasing with temperature. So for gases, it's normally the opposite, because gases, when the temperature is high, they tend to want to release themselves from the gas, from the liquid. Let's say from water, they want to release and go to the atmosphere. So generally for gases, like what we said here, solubility for most substances increases with temperature, but for gases tends to decrease. So this is a point you should just note as a rule of thumb. This is just a diagram to demonstrate for different, but you are not required to know this graph, but it's just to add your understanding. So solubilities of common ionic compounds in water. So you can see soluble compounds. So you can see lithium, sodium, potassium, and all these ammonium. They are soluble in water, and even these are with the halides. For example, if you go, these ones are soluble in water. Then acetate, which is this one, and and bicarbonate. You can see nitrate and chlorate and sulfate. They are soluble in water when they are combined. Then insoluble ones, you can see these ones. Chromate, phosphate, sulfide, and hydroxide. They are commonly not soluble in water. Then exceptions to these, you can see exception to these solubility rules include halides. Halides, we're talking of chloride, bromide, iodide. These are halides. So if you say silver chloride, like we discussed earlier, is not soluble in water. And if you take mercury and this is lead, it's also not. Then sulfates of these ones also, like silver sulfate, it's not soluble in water. Silver sulfate is not soluble in water. So basically, so these ones we will deal with them on our website when you show practical examples from the practice questions and exam preparation. So if you want to know more how you can deal with this, please you can join our community on our website for a more personalized approach to this course. So this one on YouTube is free for your consumption, and we hope it's helping you. So exceptions here, as you can see, exceptions here. Exception to this insolubility rule include compounds of those anions with group 1 metals, cations, and ammonium ion, hydroxides of group 1 metals, and barium. Barium is in group 2, but we will cover them on the practice questions, so that because you don't have to, because it's difficult, because there are many of them, so you have to focus, have a strategy of focusing and remembering them. So we'll cover it in the exam practice. So precipitation. Precipitation is the creation of a solid from a solution using usually after a chemical reaction. These insoluble solids that are formed after the chemical reactions are called precipitates. So precipitation is also used to create or produce chemicals of the highest purity. So create or produce chemicals of the highest purity. Factors that affect solubility, as we have discussed, is temperature and concentration of solution. So you should remember. So precipitation is just you react to substance. So the deposits here that are formed, they are called precipitates. So precipitation is the process of the reaction. Then the precipitates are the ones which are deposited at the bottom of the reactor or the container. So acid-base reactions. Acid-base reaction is one in which a hydrogen ion is transferred from one chemical species to another. A base is a substance that will dissolve in water to yield hydroxide, whilst an acid produces H ions. So in other words, we have an example of sodium hydroxide. When it's exposed to water, it produces the hydroxide. So the hydroxide, it means sodium hydroxide is a base. Then hydrochloric acid, when it's exposed to water, it produces H ions, which is Cl minus, chlorine ion, and hydrogen ion. So acid, this is an acid and base. So sodium hydroxide is a base because it produces OH in water. Then acid is an acid because okay, let me just correct here. OH minus, and here it produces H plus. So acid-base neutralization reaction occurs when an acid and a base react to form salt and water. So when acid and base react together, they form salt and water. This is a principle you should remember, that reaction between an acid and a base, they form salt and water. So magnesium oxide plus hydrochloric acid, so this is a base and this is the acid, so they form salt and water. This is the salt and this is the water. This is the salt, salt, and this is the water, H2O. So this one is very important. You must remember it. Acid plus base is equals to salt and water. So it will help you to balance the equations and so forth. Redox reactions. Redox reactions are reactions in which the reduction and oxidation occurs simultaneously. Reduction is the gain of electrons by a molecule, atom or ion. Oxidation is the loss of electrons by a molecule, atom or ion. So you should use this to remember. Oil rig, which means O, oxidation. It means loss of electrons. Then rig, the R is reduction. It means gain. So in the practice questions on our website, we will go deep into many of these reactions so that we can make you master this concept of redox reactions. It's very common in questions, exam questions. So let's move on. Iron which has gone through a redox reaction. So rusting is a form of redox reaction. Rusting is a form of redox reaction. So remember, redox is just a simultaneous oxidation and reduction happening in the same chemical reaction. So oxidation numbers. So when you're talking of redox, there are oxidation numbers. So these oxidation numbers will determine whether there is a reduction or an oxidation. So oxidation number is the charge an atom would have if it was in a compound composed of ions. So oxidation number rules. A molecule consists only of one element as an oxidation number 0 since it is neutral. Oxidation numbers of hydrogen is 0 since it's neutral. Monoatomic ions with only one element or one type of atom have an oxidation equal to number equal to the charge of the ion. So you can see here magnesium chloride. So the chlorine ion is minus 1 here, and has an oxidation number of -1. Then magnesium has got +2. Remember, magnesium, the ions are +2, then chlorine is -1. So since there are two of them here, it becomes -2. Since there are two, it becomes -2 to balance. So when they combine together, it becomes 0. So in a molecule or compound, the sum of oxidation numbers for each of the elements in the ion compound will equal 0. So this is what we have demonstrated here. In a polyatomic ion, the sum of oxidation numbers is equal to the charge, e.g. the sum of the oxidation numbers of the elements in a sulfate. So here, for example, SO2 SO42 minus, it's like this. So what we are saying here, the sulfate will be -2. So it means the overall charge, when you combine everything, is -2, because we are taking it from here, because it's an ion, just like the same as we did for chloride, magnesium chloride. Suppose it will be like this, 2 plus 2 Cl minus. So what we are basically saying is like this charge, it resembles everything here. So that's the same for here. The 2 minus, it means the overall charge, oxidation for everything. When you simplify it, it will give you -2. So the oxidation number of hydrogen is +1 with exception of metal halides such as lithium, hydrogen. So normally when you view the periodic table, hydrogen, it's in group 1. So it means all the elements in group 1 usually they have got a charge of +1. You see? Charge of +1. You can check them. You can keep on going down the group. You can see there are many of them. But now what they are saying in the case of lithium, it means, because remember hydrogen, it has got 1 electron. So let's say this is the nucleus and this is the electrons. So for it to be stable, it can gain an electron or lose. So when it loses, there is a plus and a minus. So basically what you are saying, if an electron is lost, it means at the nucleus there is a proton with a positive charge. So if you lose an electron, it means it becomes positive. Okay, I feel like somebody didn't understand that. So let me give a clear illustration. So this is it. You are saying it has got an electron here. Okay, let me use a different color maybe. Okay, put red here. This is an electron. But now at the nucleus, there's one neutron. Let's say the other one is, and there is also a proton. So when this one is lost, maybe it's lost and it goes into another, it means there's only one proton left, and proton has got a positive charge. So because the electron which used to be there is no longer there, it means this electron no longer cancels the charge at the nucleus. So that's why it becomes positive, because it has lost. But now let's say another electron is donated. An electron is donated here. It means that there are now 2 electrons versus 1 proton. So automatically proton has got a positive charge. So it will be -2 + 1. So the overall charge will be -1. That's why we're here. So in this case now, for lithium, we are saying lithium is donating its electron to hydrogen. That's why that's where the negative number comes. But we will discuss it more in our practice questions, so that some of these things they become clearer as you work in practical like examples and exam questions. So but for now I think you just get the idea. So thank you so much for watching, and please like, subscribe and share and comment below if this content is helping you. And if you need to contact us, there is our email on the right, and you can also use the comment sections below. Please subscribe to our channel if you haven't, and thank you and have a great day. Bye bye.